SciManDan. The nunchucks are coming out because it's a good one. Now, I'd already done a post and I'd already got the nunchucks out. I wasn't sure whether I was going to see myself on your show again for some reason. I don't know why this is. I got my cluster headaches last week, and that post that I did, where I was a little bit short maybe, I'd had two the night before. Now, I've had them for a week now. They run for about 9, 10, 11 weeks. Not much fun, but they're not too bad, okay? I'm getting one bad one every second day. I'm on meds, right? They kind of have kicked in. They're nowhere near as bad as they used to be a decade, 2 decades. I've had it for 40 years. Enough is enough. But to see my name on your show this morning, it made me sing. Not really, it's just a figure of speech. My heart was singing. Now, it's about the speed of light. Now, just a quick recap. Last week, my clusters came, so I was going to back off and I was going to read in the night from the 1961 encyclopedia. There's loads of stuff there about the speed of light. Damn. Anyway, the moon did a handbrake turn on me on Saturday night. I'm talking handbrake turn. I mean, it's coming up over the horizon. I go out there with my camera and go, in the time it took me to take 3 pictures, the moon handbrake, she's done a 90-degree turn. It's gone like that. Over 5 hours. About there in the sky to about there. She's done a wobbly on me. So I said to myself, right, last night I said, or yesterday during the day, I'm going to do a lunar time lapse again, right? Set the phone up last night, everything was good, cleared the memory on the, just ready to go. Kind of clear sky. I set the phone up, time lapse running for 10 minutes, clouds come over. You know how it is, Dan. I sacked it in the end, but what I did do, I still had bits of clear sky here and there, so I thought, right, I'll set the phone up, and I set it up out there, pointing at Centaurus, Regis, Proxima, that constellation, and a few of the surrounding ones. Let it go for half an hour, 45 minutes. I need to tell you this. And then I'll get into the speed of light. I split my time lapses up into, like that's my screen, into 6, right? So I let it play half hour, 45 minutes, and then I can watch the whole time lapse in 30 seconds. But if you watch all of it in a oneer, you miss stuff because there's so many stars. So what I do, I zoom in, whoop, and I zoom into, so that one first, second, it was the third one. I zoomed in, it runs for 30 seconds or something. In second 24.93 in the top left fucking square. Do you remember the movie with Bruce Willis? I'm sure it was Bruce Willis. Something about they had to get to the center of Earth to kickstart the freaking core or something because gravity was going to go on the blink or something. Where we heard that before? Listen, right? I drew this off of my time lapse. I get to the time lapse, I zoom in, boom, watch one, watch the second one, the third one, and there it is. It's so much action. There's loads of freaking stuff going everywhere. And I see this big, fast, right? So cool. I pause and use the finger and go back and forth, and there it is. I'm talking vroom. So I managed, luckily, it was in one of the increments. I took my finger off, and there it is. This thing is in that quadrant, right, in that square, and it's like this. a bit smaller, and then there's a star there, bright one, another star there, I think there's one down here, you know. I zoom in. What the screenshot, save to photos, exit, go into my photos, boom, boom. So I've got the zoomed in one, I zoom in again. Mamma mia. The rocket. It looks like, I'm being serious. I know there's a lot going on in this world right now, but what I do promise you, I'm not a liar. I wouldn't make something like this up. I swear, everything that is precious to me, my children, that there is no hoax, no lies. It is as you'll see it. So what I'm going to do after this, now, I will do a screen recording of me finding my time lapse, zooming into that top left sixth of the whole screen, and you'll see it. I won't even go. After I've done it, I'll go and show you all the action. They're busy. Centauri is busy. Centaurus is busy. So that was exciting. And I had that ready to go because Monday morning I wasn't sure if Dan was, there he is, Dan, internet scientist, physics, the speed of light he brings me. Dan, first of all, I listened to the whole thing. These are the main points. It's been measured countless times. Me, no it hasn't. No, it hasn't. You're presuming. Look, here is my challenge to you, right? With all you know, the methods that are being used, all of that stuff, I challenge you. With no books, no cheats, nothing, start from scratch, however you want to do it. Measure the speed of light, but show what you're doing. If you're going to spin mirrors, exactly how many times that mirror is spinning per second, what angle is what, and what each angle represents, if it's bouncing and splitting off of the silver mirror, and one goes one way and then goes the other way, and then the interference pattern. Give me a break, Uncle Dan. No. It has not happened, right? Nobody used stellar aberration. That is a load of caca. As for Io and Jupiter, Roma, listen, I'm going to just quickly pause you, grab a book. I don't know if I showed you last time. I'll be right back. Yeah, right. I found it. God, it took me a while. You don't know that though. 1955. Right? 1955. Right? The New Book of Knowledge. I'm obviously not going to lie to you. Now, what is said of Roma? I'm saying it didn't happen. Here, it was Saturn's moons, 1955. Named Old Roma, 1644 to 1710. Showed that light does not travel instantaneously, and he made quite a good estimate of its speed by noting discrepancies in the predicted and actual times at which Saturn's moons became eclipsed. Now, 1955. This stuff, it's lies. This is what I'm saying. All of these names. In my 1961, it was Roma, Io, Jupiter. In 1955, somebody thought it was wise to say Saturn's moons. It got changed between 55 and 61 to Jupiter, right? Now, you say it has been measured countless times. I'm saying to you, measure the speed of light. You've got that alpha phoenix. So many people. MIT, all of these things, stopping light, seeing it crawling through a bottle, just all this stuff. Somebody's managed to slow it right down. It's the lies. It's the insult to my intelligence that I find more offensive than the lie, right? Because nobody has measured the speed of light radiating from the sun. 8 minutes and 20 seconds. Damn. You're so wrong about this. You explain it and you're missing the speed bump. Right, you even say there is a delay across a room between me looking at somebody, that it's in the past and da. No, sir. Dan, you're doing that thing where you're falling back on previous presumptions. All of you are presuming. Unless you actually physically try to measure the speed of light, you won't know what I'm talking about. You don't think you need to measure the speed of light because you are so convinced that so many other people measured it countless times over the centuries. You're convinced, right? I am telling you, it hasn't. The light radiating from the sun is absolute. There is no delay. Let me take you to your speed bump that you just keep going over. 8 minutes and 20 seconds. So what I've done 8 minutes and 18.7 seconds to the moon. And we have a little, I don't know, a moon reflector break while I gather some rocks up and stuff. And then another 1.3 seconds for the shadow to leave the moon and arrive at the sweet spot on planet Earth. Total 8 minutes and 20 seconds. 18.7, 1.3 for a total of 8 minutes and 20 seconds. For photons to travel, to come here, invisible packets, invisible massless packets of invisible massless photons. Smoking gun? Invisible massless packets of invisible massless photons. 8 minutes and 20 seconds. Now you keep saying that you see them both at the same time. The sun, and you're stood from the sweet spot. People are stood in the shadow, aren't they? The moon shadow. So they are stood in the moon shadow that is being created by photons that are being blocked, that have travelled for 8 minutes and 20 seconds, right? Sweet spot, bang, everybody's like, oh, but they're looking up through the sweet spot. They see the moon and they see the sun's corona around the moon, don't they? So what is happening is people are standing in this is your speed bump. They're standing in the shadow. Photons have been traveling for 8 minutes and 20 seconds. The shadow, photons have taken 8 minutes and 20 seconds to get here. That sun that they're seeing around the moon, why is it there? This is the bit where you'll cut me off and go, Paul, the reason why it's there, I've told you 1,000 times, don't stop the video. It's not possible for people to be bathed in 8 minute and 20 second old photons traveling for that long, as well at the very same time seeing the light source that radiated those photons 8 minutes and 20 seconds earlier. How is it possible? There is no delay then, is there? There is no delay. You're seeing the light source be directly behind the moon, as well as the photons that left that light source 8 minutes and 20 seconds earlier. There is a gap. There is a gap of 8 minutes and 20 seconds between here and when they finally hit the moon, and then boom, shadow hits there. There is a gap. There is a delay. So why is it that the people on the sweet spot, in the sweet spot, are seeing the photons that have been traveling as well as the light source that radiated those photons 8 minutes and 20 seconds earlier? I show you the 2.08 degrees that Earth spins counterclockwise on its axis in 8 minutes and 20 seconds. And I said to you, this is where the sweet spot would have been facing when the photons left the sun. Because it takes 8 minutes and 20 seconds. And you said, yeah, but you're seeing the alignment we see happened in the past. So when Earth, 8 minutes and 20 seconds, goes bing in the sweet spot and everybody's like, nice. You're saying, yeah, you're seeing the sun and the photons, the shadow, you're in the shadow. How is that possible? That means there is no delay. Planet Earth, not planet Earth, the sweet spot, people are on this black line. They know that the solar eclipse is coming up real soon, okay? Right? They just get the call. Folks, in 8 minutes and 20 seconds, we are going to be in totality. The moon is going to be blocking the sun, right? They get the call, 8 minutes and 20 seconds. Now, 150 million kilometers away, these particular photons leave the sun and start heading towards the moon. 8 minutes and 20 seconds. In that 8 minutes and 20 seconds, don't forget the sweet spot that's going to find itself there in 8 minutes and 20 seconds was facing 2.08 degrees away from the sweet spot. Photons are on their way, and planet Earth spins anti-clockwise for 8 minutes and 20 seconds. So this is happening. Now, the sun, why is the sun, see, the sun was, the sweet spot was facing that way, right? 8 minutes and 20 seconds, is going, bang! We've got 1.3 seconds to go. Everybody's looking up, bang, the moon totally covers the sun. We know this because you can see the sun's corona on the outside of the moon. How is it possible that the photons that have been traveling for 8 minutes and 20 seconds are in action, front and center? People are standing in their shadow as they're being blocked by the moon. But why is that sun in the same picture as the photons that it launched 8 minutes and 20 seconds earlier? It can't be, because there is a delay of 8 minutes and 20, 2.08 degrees. When the sweet spot, people are in this moment looking at the moon and seeing the sun directly behind the moon. In that moment, right, in that moment, the sun, wherever it is, the real one, it is launching, it's constantly launching photons. It will be launching photons, right, that will reach here again in 8 minutes and 20 seconds. Where is that sun right now? When these people are in the sweet spot, looking at the moon, seeing the sun directly behind the moon, where is the sun? If that is an old image of the sun, where exactly is the real sun right now? Because wherever it is, what it's doing, it's launching continuously in 8 minutes and 20 seconds when the sweet spot is going to be here, and 2.08 degrees there's going to be another sweet spot, isn't there? Where is the sun for this one? Where is the sun that is launching the photons that are going to be seen for that sweet spot in 8 minutes and 20 seconds time? Where is that sun? It cannot be. It's a paradox. It's a solar eclipse paradox. That's what we have here. A solar eclipse paradox. Because it cannot happen with finite light. You cannot have a solar eclipse playing out the way it does with the sun directly behind the moon as it plays out without light being absolute. There is no delay. It is the light source itself being blocked. SciManDan, this is going to be another long one. It's impossible to do these things in 10 minutes, right? It's impossible. There is no way possible that people can be in the shadow right here of photons that have been traveling for 8 minutes and 20, right, from there. And the sun be there as well, behind. There's either a delay of 8 minutes and 20 seconds, or there is not. It's absolute light. It cannot play out with finite light because of the 2.08 degrees. The sun, wherever it is, if it's 8 minutes and 20 seconds away from where it seems to be, where is the actual sun in this moment? Where is it? You're saying that this is an 8 minute and 20 second old image, that the alignment we see happened in the past. How can it have happened in the past if when the people are standing in the photons, in the shadow being created by the photons being blocked by the moon, how is it possible that it happened in the past if the sun is directly behind the moon in real time? We know it's in real time. You see Bailey's beads in that last second of the moon just blocking the sun. That's not 8 minutes and 20 seconds old, SciManDan. Is it? Really? You cannot have the photons, the shadow being created by the photons that have been traveling for 8 minutes and 20 seconds, as well as seeing the sun that launched them 8 minutes and 20 seconds earlier. You're seeing both at the very same time, aren't you? Boom. You're seeing the sun and the photons at the same time. Boom, boom. It's absolute light. Boom. There's no delay. If there was a delay, it would be turning into the sweet spot. It's one of two. It's either bathed in photons that are 8 minutes and 20 seconds old. If that was the case, the sun would not be there. It can't be there, right? Or it's the sun directly behind the moon, which it clearly is, right? And it's absolute light with no delay. There is no delay. There's no delay whatsoever. Don't forget, this eclipse, I can put it on the flat earth, this is fun, right? This eclipse travelled from the southwest of the US and went all the way up to the northeast Canada. I think it came off the coast of Canada somewhere, like all the way up. How long did it last? 2 hours or something? How on earth did the sun stay directly behind the moon for all of that time if there is a delay? How on earth did the sun, the moon's shadow, and the sweet spot on planet Earth. That's 4 things lined up. Precise laser-like line. How do those 4 things stay lined up perfectly the way they always are if there is an 8-minute and 20-second light delay? SciManDan, when you say that you're seeing the sun, whatever, and it's an old image, and the photons, yada yada, that right there is illogical. It's a speed bump. It doesn't make sense. It does not make sense. I shoot a gun. People have said this to me as well. A rifle. Bang! It takes 8 minutes and 20 seconds for the bullet to hit the person that I just shot. I shoot. Bang! The person that I'm aiming at is now moving away from where I'm aiming. No. Bang! I'm aiming ahead of him. Sorry. So I aim, I go, right, he's over there. Bang! I shoot the bullet. He's going to be turning for 8 minutes and 20 seconds. In relation to me, the bullet is going, right? 8 minutes and 20 seconds later, the bullet, bang, hits him on the kneecap. Am I still in the picture? I can't be. How can I still be in the picture if I shot that round ahead of him? I'm just going to pause this a second. I'm back, 26 minutes. Look, I know these things drag on, but so I shoot, right? Somebody's turning on a Ferris wheel, on a merry-go-round. Boom, boom, there he goes. Bang! I fire. Bullet's on its way. Merry-go-round's going. Because of the crack shot that I am. Bang! It knocks him off the horse. As he goes down, he looks to see where the bullet came from. If it took 8 minutes and 20 seconds for that bullet to reach him, I am going to be nowhere in sight because he was traveling on the merry-go-round. I aimed ahead of him, didn't I? I didn't go up to him point blank range and go, bang, got you, mother, did I? I am a long way away from him and I fired ahead. Same as the photons. Sun fires the photons, Earth spins for another 8 minutes and 20 seconds, 2.08 degrees. How can it be directly behind the moon? This is your speed bump, Dan. It cannot be directly behind the moon. It's one or the other, the photons or the sun. You cannot have both of them. You can't be stood in the shadow of photons that are being blocked, as well as seeing in real time the light source that radiated those photons 2.08 degrees of planet Earth's anti-clockwise axis spin, 8 minutes and 20 seconds. Damn, it doesn't make any sense, mate. It's a speed bump. It isn't logical to be seeing both. There is a gap of 8 minutes and 20 seconds. How can you not see this? You keep saying it's alignment we see. It all happened in the past. There is either a delay or there isn't a delay. If there is a delay of 8 minutes and 20 seconds, because photons travel at 299,792,458 meters per second, the sun cannot be in the same picture as the photons. If it is in the same picture as the photons, and it is directly behind the moon, it is obviously absolute light. Anytime. Remember you laughed at me, didn't you, when I was outside with a stick, you and your merry men. What is he doing? He hasn't got a clue. The thing is, I do have a clue, and I am talking pure logic and common sense. It doesn't matter how far away a light source is from an object casting a shadow because its light is being blocked. It will always be the light source that is directly in line with the shadow. Always. It doesn't matter how far away it is the light source that is being blocked, not photons, massless, invisible packets of them that have been traveling for 8 minutes and 20 seconds. It's so ridiculous, right? Oh God, it drags on, but I need to be thorough. Can't be more thorough than that. You cannot be seeing both at the same time. There is a delay. It takes time to get here. It's a speed bump. It's illogical. This is where people are believing things that are illogical. You know what? I'm here now. Why would I do 2? Let me read from the 1961. I'm here. It's speed of light, Kepler, they're all there. They're all there. It's picking up some momentum down, isn't it? You see the old flat earth? I only did this to acclimatise myself. The more I see it, the more logical it's becoming. Don't forget, mate, I've been a round earther my entire life. The first one we're going to read is only a paragraph. A paragraph in each of them. Not all of those, just that first bunch. Just these ones here. 1, 2, 3, 4, 5. Just a paragraph. Bits and pieces out of each one. 1961. Now, it is said that the reason we don't feel the earth moving, spinning, wobbling, doing all the stuff it's doing is because of that inertia thing. Because we're on the ride already, we don't feel it. What is it? 1600 kilometers per hour at the equator. Another 60,000 something because the sun, we're orbiting the sun. We don't feel anything, no movement. It doesn't even feel like I'm upside down, which I clearly am, nearly, aren't I? Down here. There we are. Look, I'm hanging on for dear life. Poor New Zealand, poor Kiwis. They're hanging on for dear life. I should not be complaining. But nothing, we don't feel any of that because of inertia. That's what we're told. You're on the ride already. It's moving forward. You don't feel it. It shimmies. You don't feel it. Foucault. What did he do? Proves that the earth turns on its axis with a pendulum in the Pantheon in Paris. So it's an 80 pounds a head. So from the ceiling of the Pantheon, a large public building in Paris, Foucault hung a pendulum, right? A heavy ball weighing 80 pounds, that's 40 kilograms, suspended at the end of a 200-foot wire. Around the point on the floor over which the ball hung, he railed in a circular area about 12 feet in diameter. Then he started the pendulum swinging in a north-south direction. There it goes, tick, tick. Oscillation. Now you get a good oscillation. Tick, tick, tick. Now, this is what happens. In the plane of north-south direction, in the plane of the meridian, as it swung, always in the same plane, a sharp pin attached to the bottom of the ball cut through a ridge of sand on the top of the circular railing, right? If the earth were not turning, the pin would continue to cut the sand at one point. Boom, boom. Since the pendulum swings always in one plane, Instead of this, however, the pin actually made a new mark in the sand with each swing of the pendulum. So it starts to turn, doesn't it? It turned clockwise, which means Earth is spinning counterclockwise. Why? It's happening with a pendulum. Why does the water not slosh around the lakes, the seas? It's right here. If a pendulum is going to feel the axis spin and stuff, why does the water not budge? I'm talking about the Caspian Sea, the Black Sea, all of those, the Great Lakes. It's right here again. They say one thing when it suits, but then they say something else when it doesn't suit, right? For Cal, a pendulum. It's doing the thing because of axis spin. Why don't we feel it? If a pendulum feels it, you'd think, wouldn't you? That was why. Now, what have I got here? This mother! Newton. Right, I had a thing up here. This is about light, okay? Other men who shed light on the problem of light in the 17th century should be mentioned here. Descartes thought of light as a kind of thrust of pressure, luminous bodies, and attempt to explain its refraction in mechanical terms. He used the illustration of a man hitting a tennis ball against the wall. Descartes, I think, therefore I am, 1596 until 1650. Tennis wasn't a thing until 1870. They say that Descartes, his explanation was a tennis ball, an illustration of a guy hitting a tennis ball with a racket against a wall. That was something to do with the explanation. Tennis was over 100 years away. People say, yeah, but that could be, how many that could be are there, right? Now, number 4. BS, relativity. All of this speed of light, Io, Jupiter, the delay, Roma, it's your first nudge at relativity. It's your first nudge. Roma, his light delay was humanity's first little nudge, but there was a light delay, finite light, relativity. Didn't happen, folks. If you think it happened, get a good telescope, right, and find Io in the night sky and Jupiter. They're up there now. I don't even bother. It's ridiculous, right? And I've got a better telescope than what they had. There is no way. It doesn't happen. You cannot do it. They've even got this scrap paper that's got markings on it from the nights that he went out and he reckons he observed. He didn't have any accurate timekeeping devices. How did he do it without any? It's just one thing after another. And nobody ever gives an explanation for it. You just presume. The theory of relativity. I've just put in my little, I put BS, R-E-L, bullshit relativity, right? Because it is. It's beyond a joke. The theory of relativity. Certain theories, very few in number, have so greatly influenced scientific thinking that they stand out above all the rest. Now let's skip all of that and let's just go to the bit that y'all love. To an observer on the planet Mars, a speed of 200 or 400 miles per hour would seem insignificant compared to the 18 mile per second speed of the Earth as it revolves around the sun. But the sun itself is not stationary. It is moving at many miles per second around the center of the Milky Way, the galaxy, island, universe, of which our solar system forms a very small part. The Milky Way itself is moving with respect to other galaxies. Where then is our frame of reference? Why do we need one? This is the thing. They have pulled this light thing out of thin air and said, let's make a talking point out of this. That's what's happened, right? It's just rubbish. None of it kicks in until the speed of light. None of it kicks in. So of what use is it? Of what use is it for people to be going through these equations, and Aunt Nellie will not age if she travels at the speed of light for 5 years and her twin sister doesn't? All of it. It's just useless, pointless, never to be used properly ever by anyone information. It's a talking point. They've fabricated this stuff. No, they haven't, because we know that. No, you don't. You just presume, mate. The lies are insane. At one time, men of science believed in a luminiferous or light-bearing ether that might serve that purpose. The ether was supposed to be a... Look, I'm not going to, right? The particle BS. These are just the little headings, right? The Book of Popular Science. Here's the thing, folks. I know it might sound a bit boring, right? But these books were written in 1961. Boring or not, there is only one way for people to educate themselves, and that is either by reading stuff themselves, doing research, or believing what other people tell them. Right? Now, you guys have been lied to. It's obvious that you've been lied to. The only way you will find out if you have been lied to, and I guarantee you, slam dunk, that you have been, especially about light, is by doing some of the observations yourself. And nobody will do it, because you just presume the next guy has done it. Presumption. And the trust of the innocent is one of the liar's most valuable tools. Right here. Sun, moon, sweet spot shadow, all in line. 8 minutes and 20 seconds. Mamma mia. Right. Just little bits. Particles. Suppose now that we have located 2 points, P1 and P2. We want to trace the movement of a particle from P1 to P2. Why? Who knows anybody that wants to track a particle from P1 to P2? Nobody does. CERN, guys, they are not doing what they are telling you they are doing. Ordinarily, we would take a time reading when the particle is at P1 and another when it's at P2. Sounds simple. Or rather, when we would see the particle arrive at P1 and P2, time readings of this sort would not be absolutely accurate, because it would take time for light to travel from a light source to the particle and to be reflected from the particle to our eyes. That's what you were saying, SciManDan. Listen, our eyesight, it's absolute. It complements light. Every single light source that anybody ever sees, you're seeing it in real time. Any light source that anybody ever sees is being seen in real time. You're not seeing delayed light. There is no such thing. This thing let's say 12 Ks. You have somebody at Ks 1, 2, 3, through to 12, to 15, to 20, right? Everybody is wired into a button, goes into a main box. We're going to time everybody. Person who turns this on, and everybody's facing this way in the middle of the night, can't see anything anywhere. Guy presses the button. Bang! The guy at the last kilometre will see the light at the exact same time as the guy at the first kilometre. No measurable delay whatsoever. It would be reflexes. Boom! The person with the fastest reflexes would be the one to bang in first. There is no delay. At 14 kilometres, cannot be seen. I could stay there for a week, couldn't I? Is the light going to reach the person that is out of range of the light source? If no, why not? Does it not travel forever? Guys, it's this breakdown of common sense and logic. You then have the sun and loads of different size light sources in between. Get to the sun. It turns on, its light will radiate to as far as it's going to go at absolute speed. People on Pluto would see whatever the sun was doing at the same time as people on Mercury. The same as the 1, 2, 3, 4 up to 12 Ks with the people. It's a light source. If you can see a light source in the night sky, you are seeing it because it is powerful enough to be detected by your eyesight. You're not looking up at the night sky and seeing stuff. The youngest we have is Proxima Centauri at 4.2 light years away. It's ridiculous to think that you're looking up all of those stars and none of them are there because the light has taken that long to get here. It's so stupid, but it's as stupid. Did I tell you about my space rocket? Coming up after. It's so stupid, but it's being taught. It's being drummed into people, right? It's fake science. The only way to prove it is by one of you, or all of you, try to measure the speed of light yourself. You will not be able to do it. You will not be able to do it. Telescope anything you want. You will not be able to measure the speed of light, especially that coming from the sun. You will not be able to. Every single thing that you've ever seen telling you that X amount of people have measured, they haven't. It's presumption. Why on earth would in the 16 and 1700s so many people be doing all of this stuff? None of it needed until 1969. Why? So nobody thinks about, well, you do, but you don't think it's a point worth bringing up. It is, trust me. These things, right? All of those people, France, Germany, Holland, Italy, the UK, all over the place, 1700s. They didn't know each other. They make it sound all cozy like everybody's in correspondence. There was no electricity until 1880. It would have taken months to go from one of these places to one of the other places. Horseback. It's all of this stuff, right? You've read the stories and you do not have enough critical thinking abilities to see through all of the thousands and billions and trillions of cracks that there are. And believe you me, there are some cracks. This stuff the discrepancy between the apparent and actual times of arrival of a particle at a given point would not be significant ordinarily because of the great velocity of light. It would be so small even at a speed of 1/10 that of light. That is 18,600 miles per second, that it could be detected only with the most refined measurements. But at a speed of 1/2 that of light, 83,000 miles per second, the discrepancy would begin to be apparent. But who is going to be doing this? This is what you don't understand. You're talking about stuff that is pointless. All of it. It's all pointless. It goes nowhere. If it were at 90, it would be great at 9/10 the speed of light and enormous at 99 hundredths of that speed. Look, it's just, if we were to chart accurately the progress of a particle at such great speeds, we would have to apply the special theory of relativity, which takes into account the time needed by light to traverse space. We could make the necessary calculations with accuracy, for the speed of light always remains the same. I can't do it. It's so stupid. The thing is, there's loads of reasons, every reason why it's stupid. The people who did it, why they did it, when they did it, for what they did it for. None of it adds up. But we don't ask those questions. We just know that half of Europe was working out space travel in the 1600s, don't we? Now, Newton, like we're getting there. Newton, BS. That's what I've got. Newton, BS, 51 minutes. Look, there is no shortcut to this stuff. The tides. The tide raising effect of the sun is only about 4.46 times that of the moon, in spite of the fact that the mass of the sun is about 28 million times greater. According to Newton's, see there it is, law of universal gravitation, the force of attraction that various bodies have for one another is directly proportional to the product of their masses, but inversely proportional to the square of the distance between them. 1600s. No power, no electricity, no anything, no calculators. Huh? What? The sun is about 93 million miles from the Earth. The moon out, it just goes on and on and on. Then we've got the bulge thing. But why does the water not do like the pendulum? Why does it not? You'd think it would, wouldn't it? It's only 200 feet. Some of those lakes, 1,000 feet. The water, it would be sloshing all over the place, wouldn't it? No, of course not. The reason that they give, I don't know. But the pendulum, it's detecting. Knowledge being, see this is how fast we're getting through. Knowledge being claimed that cannot be known. All right? What's this one about? The stars. How do people believe this rubbish? 1961. The billions upon billions of stars in the heavens are so far away that, with the exception of our sun, they are visible only as points of light. The sun alone shows a distinct disk. Where's my cup of tea? A distinct disk, and we can make out many details of its surface. As a result, astronomers have been able to learn much more about it than about any other stars, of the other stars. The sun is a typical star, differing from most others only in scale. Hence, a brief survey of its features will help answer the question, what sort of body is a star? The sun is a globe of glowing gas. Despite its apparently sharply defined disk, it has no solid surface. Its diameter is about 109 times the Earth's, and its volume is more than 1 million times that of our planet. However, it is much less dense, and its mass is only about 330,000 times that of Earth. Estimates of its surface temperature range from 7,500 Fahrenheit to 10,000 Fahrenheit. The temperature of the center may reach 30 million Fahrenheit, 1961. The elements present in the gases of the sun occur also on the Earth. The lightest of these elements, hydrogen, is by far the commonest. Roughly speaking, the heavier elements are progressively less frequent. How did they know this in 1961? I'm being dead set serious. How did they know in 1961 all of this stuff? It's crazy. The surface of the sun shows a delicately mottled and swiftly varying pattern. Large gaseous clouds hang. Look, I'm not gonna. Now, I say, how did they know this? We're going on to the last book. Ah, thrust. Book 10. This is the index book. It's a set of 10 books, right? (1961). Space travel. Men's future journeying beyond our atmosphere. Buckle up, Dorothy. Slam dunk. It's lies. It's so obvious that the sun is directly behind the moon during the solar eclipse. So obvious. Yet curiously enough, a device that can bridge the gulf of space between the Earth and other heavenly bodies has been known to mankind for many centuries. This device is the rocket. Ronnie the Rocket. It is based upon Sir Isaac Newton's third law of motion, which states that for every action there must be a reaction equal in force but opposite in direction. 1666. Referring to the vacuum of space. 1666. What do you reckon? A vacuum. Ay. This law explains the recoil of a gun or rifle. Corresponding to the forward thrust, there is a backward thrust, which in the case of a big gun is very formidable. In a rocket, the firing of the fuel causes gases to be expelled at high velocity from the rear. The recoil causes the rocket to dart forward in the opposite direction. Right? But in a vacuum, it's not an action. It's nothing. It's not going to work against, with, sideways. There is nothing, no resistance for any action to take place in a vacuum. So the initial action, nothing has taken place. Again, it's common sense, right? It's common sense. I know that. I know. You hate it. As long as the rocket fuel burns and shoots out billions and billions of molecular bullets, the combustion gases, there will be a recoil that will push the rocket ahead. But there won't be in a vacuum. Because, and this is another thing, if you had a sniper or a 12 gauge shotgun and that was your thrust, bang, 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 would you move backwards after shooting a 12 gauge in a vacuum? It's a toughie. But thrust, it's not explosions. It's not a sudden brute force, a single moment in time. Bang! Is it? It's not even in the same ballpark. Same people that compare the sun radiating its light and a hose squirting water. These comparisons are caca. They're common sense defying trash. They just are. Its thrust does not depend on the presence of air. The device would function even more efficiently in an absolute vacuum, since there would be no air to resist its forward movement. So not only do they lie, blatantly lie, they rebuy and go all in again, telling people that it would be more efficient because there is no resistance. No, there is no resistance. Every action does not have an equal and opposite reaction in the vacuum of space. The path of least resistance. It's common sense. The path of least resistance. Why on earth? This is why. And people will be going, yeah, but we've got reflectors up there. Well, you haven't. You presume. All of these telescopes everywhere. Why can we not get a freaking picture of the flags? Why? If NASA is doing everything that they say they are doing, we would have so many live streams, so many live feeds everywhere, because they would want the world to know how smart they are. But they don't. Everything is cagey, controlled, precise, lies. If you've got a thruster, right? The rocket's coming down. You're in a vacuum, total vacuum of space. You're hurtling towards the moon, right? You put your thrusters on. Comes flying out in a vacuum. What on earth makes people think that this that's coming out of here is somehow going to find the will to push up and slow this down when it can simply vent into the vacuum? The path of least resistance, for crying out loud. It's the path of least resistance. Everything takes the path of least resistance, especially in a vacuum. Guys, you're being had. You are being had. I'm not even going to go any further into this because, and the last one, a trip to the moon. There's going to be one more after this, but I will make it painless. I'm going to pause it for you because it's just more of the same, right? I thought it was going to be here, but it isn't. Right, are you ready? Are you ready? A trip to the moon. See? It's worth a read. 1961. Do you mind? I might go there and say something. Nah. The spaceship that will make the trip to the moon will be set in flight by the combustion of fuel and will be headed towards our satellite. Then the power will be shut off and the ship will coast towards its goal. I'm telling you what's going to happen in 1969. It's 1961. They're telling you what's going to happen. The trip will take only a few days. Of course, as the ship approaches the moon, it will enter that body's gravitational field. To avoid a crash, the ship will be reversed in space so that its rocket motor is facing the moon. I mean, that maneuver that they did. These guys jumping in a rocket in the command capsule thing, as you're hurtling along at the escape velocity of Earth, 25,000 miles per hour, and you jump in. Who did that? And you reverse out. You start the rocket out, thrust in a vacuum, and you come out, stop, turn, and reverse back in. How we going, Buzz? Yeah, keep coming. Come on, Neil. Giddy up, foot off the clutch. Slow her down. Seriously, it's the things that people believe, right? That's what they did. They literally, one of them jumped in and started the rockets up, and eased out of the nose of the rocket that was traveling like the clappers and did a shimmy, did a 180, and then reversed back into the nose of the rocket or something. They did this for every single one. Taking buggies to the moon. What is it? What is it that people really cannot see about this? It's insane. It's worrying. It really is. To avoid a crash, the ship will be blah, 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 blah. As the gases of combustion stream out towards the moon's surface, the reaction will cause the ship to slacken its speed. There is no taking the path of least resistance here. No. Thrust is going to push up on that rocket and it is going to slacken its speed. At the appropriate moment, the motor will be shut off and the ship will land. Well done, Neil. Thank you, Buzz. You right there, Michael? Where is he? He's been travelling for 4 days and we've just left him orbiting the moon. And he's going to orbit the moon on his own for 30 orbits as we are 60 miles, 70 miles away from him on the moon. And we've still got to get back there. It's the things that people believe. It's insane, right? After spaceships have made several trips to the moon, venturesome astronauts will be ready to launch on other trips in space. It is probable that the second heavenly body to be visited will be the asteroid or minor planet Eros. It comes closer to us at perihelion, the point closest to us, than either Mars or Venus, our neighbouring planets. Since Eros is tiny, its gravitational field should not present any serious problems to a spaceship approaching it. 1961, no problem whatsoever. Moon, we'll get that banged out 6 times and then we'll head for Eros. The first-hand investigation of a minor planet would be of enormous scientific interest. Please, make a list. Be specific. Be specific. What do you have? What do you have? Other than stones, selling them for something like $50,000 a gram. At least that. What scientific anything? It's just this presumption of everything. Perhaps the most intriguing goal for space explorers would be the planet Mars. We don't need to do the other one, it's right here. We have learned quite a good deal about this planet. We know that it has polar caps whose size varies with the seasons, that there are barren areas, probably like our deserts, that there are certain dark regions that undergo seasonal changes and that probably contain vegetation. 1961. Regions that undergo seasonal changes and that probably contain vegetation. We can make out certain markings that some astronomers have taken to be canals constructed by intelligent beings. 1961. It will be most gratifying to add to our knowledge of Mars. We shall want to learn what kind of deserts it has and what kind of vegetation. We shall want to find out if there are intelligent beings on the planet. We shall want to solve the mystery of the so-called canals. According to present calculations, a trip to Mars would take about 258 days. 1961. All these telescopes. But in 1961, they still thought there was vegetation on Mars. It's here in black and white. It's the absurdities. They're not adding up. Now, Dan, I'm sorry it took so long, but there is no way to rush this stuff. There is no way. You've been taught this stuff from children, from when you were young, and they have lied to you. Blatantly lied. I'm going to pause you. Right, clear that out. I'm now going to unpause you. So I'm going to do this. Some of you would have seen it. I haven't had it down in a couple of months. It's been a while. You know the pattern things I talk about, SciManDan? This is better than the book, right? One day there's going to be a python on here, an anaconda. It's going to come up, take my fingers off, isn't it? Spiders, Christmas beetle, an Aldi token that I use for a moon. The first month or so, when I started this thing, this place, this classroom thing, I know it's lies, right? Now, you have Copernicus at the top, born 1473. In 1510, he did whatever thing he did, I can't remember all of them now, and died in 1543. Galileo! Born 1546, did his thing, whatever it was, in 1610, and then 1642, kicked the bucket. All of them, right? They did their thing, it's the middle one, you know, speed of light, whatever, the main thing that they did. And that is the die. Born, thing, die. Now, Tycho, 1546. In 1570, before the telescope, right? Unprecedented astronomical observations and predictions. Kepler, 1571 to 1609. Planetary motion, elliptical orbits. No. Where's our man? Isaac Newton, 1643, 1687. One of these many things. Kicked the bucket in 1727. 3 laws of motion and various others. Olaus Roma, 1644, 1676, speed of light, Jupiter and Io. Now here's one. Joseph Lagrange, 1736, 1880, electricity, okay? 1880, Joseph Lagrange in 1772, 108 years before electricity came along. Don't forget this, okay? All of these people here, they didn't have any calculators. They didn't have any power. They didn't have anything. But they worked everything out that was needed for that in 1969. Nothing. They had nothing. Poland, what's that? Italy, Denmark, Germany, Netherlands, that'd be Holland, France, France, Italy, France. What's that? Oh, UK, Newton. It's people. This was Europe, 1600s. There was bandidos. Give us all your money. There was nothing. There weren't even tracks and roads in some places. There wasn't like ferries going from Dover to Calais every 20 minutes. There's this speed bumps all over the place in all of this stuff, right? And nobody's picking up on it. Why? Do you people honestly think that between, forget Copernicus, that between 1610 and, let's go to Joseph Lagrange, it's 160 years between 1610 and 1772 in Europe, in all of these different countries, not connected, they didn't know each other, they just so happened, all of these people found themselves acquiring all this knowledge before there was any artificial light. They would have had candles, paraffin lamps, oil lamps. You've got that freaking Christian Huygens. Where is he? Huygens, there he is. Centrifugal force, Saturn's rings, and the wave theory of light. Light is propagated. The crest of a wave, and then another wave, and another wave. All of this before electricity. All they had was sunlight. How do you get that from sunlight? Oh, Newton, he procured a prism in the 1600s, a prism that was that good that it could split the sun's light. He procured a prism and placed it just next to a hole that he had cut into some blinds or something, and the sun's light spread out into his chambers. And oh, Newton, how did he do so much? And then gravitation, and I mean, the guy just didn't stop, did he? No calculators, no nothing, just an apple falling from a tree and his imagination. Folks, listen, I strongly suggest that people backtrack with this stuff. The easy one is the speed of light. Dan, I challenge you. You say, measured countless times. Do it. SciManDan. Do it. Don't cheat. Show us how you do it. However you want. No marshmallows in a microwave and measuring the little gap. It's the things that people are believing. They've made people stupid. They've made people stupid, and they've made you people, the majority, think people like me are nutcases, conspiracy theorists. But we're not. I am objective. Makes no difference to me whether they went to the moon or not, really. It's obvious they didn't go, but what does matter is the direction that humanity has gone in because of the lies. They're big lies. They're not the little porky pies. I'm not coming out tonight because I have to wash my hair. These are the lies that affect people's lives, right? And the people who are lying to maintain a certain lifestyle, control over other people. They lie. They make stuff up to take advantage of a situation. Can we not see this? Look at the cars and the vehicles that they have, and the houses that they have, and the money that they have compared to everybody else. Money is what makes the world go round. The trust of the innocent is one of the liar's most valuable tools. And Joseph Lagrange, born in 1736, did his thing in 1772, the three body solution, and that in Lagrange point 2 is where the James Webb Space Telescope finds itself. Now, isn't that handy? It's very lucky. I mean, Kepler, it's a good job he worked out the motions of the planets, eh? And then we've got Newton. Luckily, every action has an equal and opposite reaction because, you know, and there is no taking the path of least resistance in that one. Descartes, thinker, I think, therefore I am. And when he was talking about his version of the problems with light, his illustration, his explaining was a diagram that started with a tennis racket, bang, smashing a ball against the wall. Something to do with photons, I don't know what it was. But tennis didn't come out until 1870. Albert Einstein. Why on earth would he have called a photon in 1905? Having witnessed solar eclipses, it's very, very obvious where the sun is, and to think that photons are somehow involved, it is a lack of common sense, because the sun is clearly directly behind the moon. So why on earth would Roma have freaking detected a delay? It's just so much rubbish. It is. Galileo Galilei, the guy that possibly invented the telescopes, hand slipper sheet. Look, the insults to people's intelligence, it really is something. It really is. There's a couple of those. What are the other ones? There's a few of those names, like hand slippery. But then we had the thing about the spectacle makers' children, isn't it, with the lenses. Oh, Dad, look. Oh, been working with those for how long? I didn't realise that if you put two together, that looks a bit closer. Telescope. It's the stupidity. They've made people stupid. Slam dunk. The majority of these are lies. Slam dunk. What the claims are lies too. Slam dunk. It's all for this. We're going to get there by the end of the decade. They didn't go to the moon. Slam dunk. 1969, 1972. 6 successfuls. Can people not see what's happening around them now? Was there one more thing? Yes. This is the last pause. Look at this. It's like a full-length feature movie. 123. The very last one coming up, guys. SciManDan, this one is for you. And we are at the finale. Okay? SciManDan. The weather should be warming up slowly where you are. Turning here. It's raining now. Eclipses. You say they can predict them. Yes. But because of the patterns in the past, the interval between an eclipse of the sun or moon and the next one in a given series is called a saros, a Greek word derived from the Assyrian Babylonian word sharu. Each series is 18 years and 11 1/3 days long. For 18 years and 10 1/3 days long. If there are 5 leap years instead of 4 in a saros, there will be each saros is 18 years and 11 1/3 days long, or 18 years and 10 1/3 days long if there are 5 leap years, right? So if the first one is in a leap year, you get 5. If it's not, you get 4 in the 18 years. because there's a leap year every 4th year, right? They run, a given series of solar eclipses may run through as many as 70 Saroses and may last for 1,250 years. What this means, I mean, to work this out back then, right, what happens is nobody knew when there was going to be an eclipse at one stage. Like, oh my, what's happening there? The sun blocked by the moon. Now, the very first time a Saros begins, you would get the sun and the moon. The first one would be just a sliver, right? Somebody would go, hey look, is that the moon in front of the sun? And it would maybe just go like that, right? And then move that way or that way. But just a little bit of the sun blocked by the moon. 18 years, what was it? 18 years, 10 1/3 days later, it will happen again in the same spot. But this time, there will be a little bit more of the sun blocked by the moon. And off they go again for another 18 years, 10 1/3 days. And then it would happen again, just a little bit more. That's 3. And that would be 18, that's 54 years. In one Saros, there can be 70. It takes 70. So what we could say is at 35, you get the full solar eclipse, and then 18 years and 10 1/3 days after that, you get nearly a full solar eclipse, but not quite. And then for another 35 Saroses, you'll get less, until finally the moon just misses the sun altogether. 1,250 years. That is how long one complete Saros, one complete series of just one solar eclipse can last. There can be 3, 4, 5 happening at the same time. Like one here this year, and then in 18 years, the next part of it will happen. But there could be one in Japan in 3 months, and then they have their series of eclipse. If you took, see, a lot of people probably think it's up here, don't they? Kepi, elliptical planets, the planetary motions, we know where they're going to be. We can work anything out. No, they can't. The reason that there is a what's it called? The what chart? Opposers tables, right? Look it up. The guy is called, I don't want to mess this board up. Opposer chart. That's right. Opposers tables. This guy, because they worked it out, they passed the baton to each other for 1,250 years, they worked this stuff out. That is how long it took to work out one series of eclipses. 1,250 years. That is a lot of passing, that's a lot of generations, isn't it? That is how they know when the next one is coming, right? Maybe now there's been that many, right, that don't tell me Newton invented calculus. I think that's the one, isn't it? He invented calculus. He invented, first of all, he came up with gravitation, the apple falling, right? It's not to do with eclipses, but it's gravity, same kind of absurdity. The apple fell, And he went, oh, I know, gravity. Now what I need to do is invent calculus or whatever. A system that I can use to explain my theory to the world. So I invent a theory of gravitation because of an apple falling, but now, somehow, I've got to come up with calculations, right, that explain everything that's happening. Can you not see where the speed bump is? Invent something, and then you invent the math to go with it. The math wasn't already here. There is a difference there. They invent stuff. Hypothetical and theoretical particles. If something doesn't add up, just throw a couple of the hypothetical ones in. 2 of the red ones and an orange one. Give me the blue one as well. Put that one in my pocket for later. Because you just know that I'm going to bump into other problems on the way. I'll throw another theoretical particle in. And we'll use that for the next 50 years until we've worked out if it works or not. Then we could subtract a few and put another few in. There is so much knowledge being claimed on this planet that cannot be known, right? But people are oblivious to it because that's what you've been taught. But I'm objective. I'm self-taught. I don't suffer from Dunning-Kruger. I use the facts, the patterns, the obvious patterns, knowledge being claimed that cannot be known, and achievements have been claimed that won't ever be achieved. I'll leave you with a thought. The Parker Solar Probe got to within 4 to 5 sun diameters of the sun, got caught up in a solar flare. It was in the solar flare, in a coronal mass ejection. No sweat. It's got that white shield and carbon-carbon to protect it. And a radiator and a gallon of water. What did it do? It recorded. It was in the solar flare. It recorded all of the action. You must have seen the ridiculous footage and somehow sent it back to Earth. So that everybody, for your perusal, so you can check it out. Peace, SciManDan. Slam dunk, lies, right? Slam dunk. And I know you don't like it, but that solar, the sun and the speed of light thing, mate, it's common sense. Of course, the sun is directly behind the moon during a solar eclipse. It's the light source being blocked. There is no such thing as a light year. Light source, you either see it when it turns on, straight away, or you don't see it at all. If you're out of range of a light source, that's it. You don't see it ever. There's no such thing as a light year. They don't look into the past with those telescopes. Good old Lagrange, good old James Webb Space Telescope up there, hovering around Lagrange point 2 that was discovered, the three-body solution, back in 1772, 108 years before electricity. No calculator, nothing like that. Nothing, just, you know. It's ridiculous, mate. The insults to people's intelligence is, they're just out of the ballpark. They skipped the ballpark, skipped over the parking lot, skipped over the Kmart, the Walmart and the TJ Maxx, and still travelling now. Just like the Voyagers sending data back 1970s hardware. What have they done to you, poor people? All right, folks. Dan, thanks for having me back on, mate. Thank you. Peace out.